In Lesson 30, we're looking at deductive reasoning, Euclid. Vertical angles are equal, corresponding interior and exterior angles, and 180 degrees in a triangle. Alright, the first section A talks about a three-step deductive reasoning process, which is syllogism. And it's where you have three different things: a major premise, a minor premise, and a conclusion. Now, if your minor premise and major premise are lined up correctly and with your conclusion from the minor premise and major premise, then you'll have a valid argument. But if it's twisted around, then you will not have a valid argument. So this first example, we have the major premise: all squares are rectangles. The minor premise is quadrilateral ABCD is a square. Then our conclusion, quadrilateral ABCD is a rectangle. Now this is valid because they line up. All squares are rectangles, and they give us a quadrilateral that's a square, so we can conclude that it is also a rectangle. Okay, so let's look at another example. So first, the major premise: all poets are poor. Then our minor premise: Roger is poor. And then our conclusion: Roger is a poet. This is invalid because it told us that poets are poor. It didn't say that all poor are poets. So this was twisted around and it does not work. It was invalid. Okay, another example, our major premise: all chickens have 3 legs. And our minor premise: Henny is a chicken. And then our conclusion is that Henny has 3 legs. This is valid as far as arguments go. Even though we know that chickens don't have 3 legs, it's still a valid argument because we're just going by this major premise, and we could say, if it was true, that Henny has 3 legs. So this hasn't been reversed or twisted around, and we didn't add anything to it. So it would be a valid argument even though we know that's not true. Okay. And another example here, our major premise: if it rains, I will go to town. And our minor premise: it did not rain. And our conclusion: I did not go to town. Now this is invalid because our major premise doesn't tell us what will happen if it does not rain. It just says, if it rains, I will go to town. It didn't say what would happen if it did not rain, so it is invalid. Right, the second section on Lesson 30 is about Euclid. Now it does go into how Euclid was a Greek scholar and lived in Alexandria, Egypt, but the main points that you need to get from that are these 10 postulates, because we use them whenever we are doing proofs in algebra and geometry. So first one, 2 points determine a unique straight line, because you would line them up and you could draw a line. The second one, a straight line extends indefinitely far in either direction. So if you think about that, whenever we draw our lines, we usually put the arrows on the ends because they could keep going. And our third postulate, a circle may be drawn with any given center and any given radius. So circles can be very big or very, very small. Fourth postulate, all right angles are equal, because all right angles are 90 degrees, so that makes sense. Fifth postulate, given a line in and a point P not on that line, there exists in the plane of P and N and through P one and only one line M, which does not meet, should only have one E, the given line N. So it's just saying that if you have a point somewhere that's not on a line, and you've already got the line drawn, there is a line you could draw through P that would make a parallel line, okay? Then the sixth postulate, things equal to the same thing, are equal to each other. So we've used that already for substitution whenever we've solved systems of equations. The seventh postulate, if equals be added to equals, the sums are equal. So if you have something that equals the same thing and you add them to another something that equals the same thing, then they're going to give you the same answer, which that makes sense. It's just an interesting way of putting it. Then number 8, if equals be subtracted from equal, the remainders are equal. Again, it's just saying that you have something that's equal, and then it's subtracted from something else that was equal, and the remainders are equal. So a subtraction problem, if you have different things that are equal and you're subtracting them, you're going to have equal answers. On postulate 9, figures that can be made to coincide are equal or congruent. Okay, so you can make the same shaped figure with the same angles for each of its vertices, and you could have congruent figures. So you could draw them exactly the same. And number 10, the whole is greater than any part. So if you have something, say like a circle, you're not going to have a degree of that circle that is more than 360, because 360 is the whole part. And you could think about that with triangles or squares. You know that a triangle only adds up to 180 degrees, which we're going to be looking at here in a little bit. And you won't have any part or any of its three angles that are more than 180 degrees, because that is all of it. So that does make sense. Alright, and then on to vertical angles, part C. Vertical angles are equal. Okay, so if we look here, we know that x plus z would give us 180 degrees because they would make a straight line here. And I also know that p plus z would make 180 degrees because it makes a straight line. So these would be equal. If you go back to equals be added to equals, the sums are equal. So because both of these would add to the z and give us 180 degrees, they must be equal. Okay, and you can do the same thing for y and z. So y plus x would be 180 degrees, and x plus z would be 180 degrees. So since I'm adding them both to the x to get 180 degrees, they must be equal. So that's why we can say that vertical angles are equal. Okay, in section D we've got corresponding interior and exterior angles. Now before we've just said small angles and large angles. And what we need to keep in mind, that's what you need to remember, is alternate exterior angles are equal, alternate interior angles are equal. And you could use the same validity that we use with the vertical angles to see that these angles are corresponding, and if you added this large angle to this small angle, that would give us 180 degrees. And then this large angle to this small angle is 180 degrees, and since these are vertical angles that equal the same, then these two must also be the same. So we could go through all of that again, but please remember that corresponding interior and exterior angles are equal. Okay, Then our last topic is 180 degrees in a triangle proof. So what we've done is extended the lines on a triangle so that we would have two lines here that are parallel, and then we would have two lines that would be transversals that would cut through the parallel lines. And just like we talked about earlier, alternating interior angles are equal, so this is A, and it would be equal to this angle up here, which we've also labeled A, because those are alternating interior angles. Those are going to be equal. And then with angle C, it is also equal to the alternate interior angle that is above it there, so I've labeled that C. And since those are two angles in our triangle, if we add them to B, we know that they would be 180 degrees, because, as we can see here, all three of those angles would make a straight line, which is 180 degrees. So that's the basic proof that they go through in your book. You won't have a lot of proofs at this point in time that you personally have to do, but later on you will have to do proofs. So you'll want to get accustomed to the postulates and understanding how things are related.